Hey guys, today we're going to talk about one-step equations, as you can see here. So my first equation is a plus 1 equals 0. So one-step equations, think about all of the examples here. They should require us one step. There's going to be a case that is considered a one-step because you could do it in one step, and we'll talk about that. So starting here, there's always going to be something to undo. So you want to look, where's my variable? Here it is. What's happening to the a? It's being added by 1. How do I undo a plus 1? Well, I subtract it. So then I have a plus 1 minus 1. That's left me with a. Then on the other side, I've got to also subtract 1, and I have 0 minus 1, which is negative 1. So that means the value of a has to be negative 1, nothing else. Only thing that I can plug in for a is negative 1 plus 1 to get 0. If I plug in 7, is 7 plus 1 0? No. The only thing that will work is negative 1. That's what solving equation says. So, for number 2, b minus 3 equals negative 7. Undo it. Well, what's happening to the variable? It's being subtracted by 3. So the opposite of subtract 3 is add 3. b minus 3 plus 3 leaves me with b. To also do it to the right side of the equal sign, and negative 7 plus 3 is negative 4. Cool? So now here, I have negative 2c equals 14. Undo the variable. Well, what is even happening to the variable? If I don't see an operation, that means it's multiplication. So this is really negative 2 times c equals 14. So to undo multiplication, I do the opposite, which is division. So this fraction bar here represents division. So I have negative 2c divided by negative 2. That is going to equal 1c, which is just c. And then 14 divided by negative 2 is negative 7. All right, cool. Keep going. Number 4. I've got d divided by 8, or d8ths, equals negative 7. That is a fraction bar, which is division, so I have to do the opposite, which is multiplication. So I've got to divide. It's already being divided by 8. I've got to do the opposite, which would be to multiply by 8. When I multiply by a fraction, I have to keep it a fraction. So I multiply this by 8. I've got to change 8 to 8 over 1. 8 over 1 times d over 8 is going to give me with just 1d, which is just d. And negative 7 times 8 is negative 56. All right, last one that we're going to do, we've got 2/3 x equals 18. Now, I'm going to show you in one step because technically it is one step, but there are some that like 2 steps, so pay attention. So what's happening? Well, I've got a fraction times the variable, x, times. I have to undo. How do I undo multiplication? I multiply. How do I undo multiplication? I divide. So division, but I'm dividing by a fraction. And if you recall, dividing by fractions, there was this rule. Like, for example, 1/2 divided by 3/4. Just picking numbers that aren't the same. 1/2 divided by 3/4. You would keep this the same. You would change division to multiplication, and you would flip fraction. So here you are doing the same thing, keeping 2/3 the same, and then you're multiplying by the reciprocal. And you can kind of see why now. 3 times 2 is 6, and 2 times 3 is 6. 6 divided by 6 is 1. Right? They cancel. 2 cancels with the 2, and the 3 cancels with the 3. You'll have 1x, which is just 1. Now if I multiply the left side by 3 over 2, I have to do that to the right side. So I have 18 times 3/2, which means you do 18 times 3 divided by 2. 18 times 3 is 54, divided by 2 is 27. You could also do 18 divided by 2 first, which is 9, and 9 times 3 is 27. Sometimes with big numbers, it's easier to divide first. I say divide when I want to say, I say multiply when I want to say divide. All right, so here's this same equation, 2/3 x equals 18 in purple, and doing 2 steps, even though it's technically a 1 step. So I've got 2/3 x equals 18. If you take care of this fraction one bit at a time, because it's divide by 3, I'm going to multiply by 3. Those then cancel, and I'm left with 2x. 18 times 3 is 54. Then I have 2x equals 54, this in black here. So then I undo what's happened to the variable. I divide by 2, and then x equals 27. All right, cool. That's one step.